Welcome to my page. In our previous video, we did logarithm with table. This example, we also solved them, applying the laws of logarithm. You will recall that we also did indices, and I said indices is somehow related to logarithm. So let's see how we can convert this to index format and solve. Number one, we have log 125 from 125 to base 5. In index form, if you want to apply in index form, you say let log 125 to base 5 is equals to x. You can represent it with any letter, but I usually use x. So now this s becomes the power of the base, and everything will be equals to what? The real number, which is 5 raised to the power of x equals 125. So this is already exponential equation. And in exponential equation, you make the base equal or you make the power equal so that you can eliminate one of them. So with this, we are going to make the base equal and say 5 raised to the power of something will give us 125. So 5 raised to the power of x equals 5 raised to the power of 3, which is 125. So x is equals to x, because you know our rule, x is equals to 3. Therefore, log 125 to base 5 equals 3. That is the solution. But in the previous video, we applied the laws of indices by saying log 125 to base 5 equals log 5 raised to the power of 3 to base 5. And this 3 will come back to be 3 log 5 to base 5. And you know, in our logarithm law, log of the same base is what? 1. And so that is how we arrive at our 3. So between these two methods, you can choose which one suits you best, and you will arrive at the same answer. So let's solve number 2. Number 2, let log 3 to base 9 equals to x. So like I said before, x become the power of 9, the base, and everything is equals to the real number. That is in index form. In index form, 9 raised to the power of x is equals 3. And therefore, I told you before, it's either you make the base equal or the power equal, but in this case, is the base we can make equal. So 3 raised to the power of 2 will give us 9 times this, which is 3 raised to the power of 2x equals 3 raised to the power of 1. Base equals to base equates powers. So therefore have 2x equals 1. Then we divide both sides by 2x by 2. We have 2x over 2 equals 1 all over 2, which is equals to x equals to half. Therefore, log 3 to base 9 equals 1 over 2. You can check with the previous video. You will see that we got the same thing. Number 3. So let's do the last one. which is log 0.25 to base 8. You can say let log 0.25 to base 8 equals x. X becomes the power of 8. X becomes the power of 8 in index form. We now have 8 raised to the power of x equals 0.25. So we convert this one to fractions. Let's know what it will come out with. Now I have 8 raised to the power of x is equals to 25 over 100. 25 here 1, 25 here 4. I have 8 raised to the power of x equals 1 over 4. Now we have arrived at this. So we can say 2 raised to the power of 3 will give us 8. And 2 raised to the power of 2 will give us 4. And therefore, write it as 2 raised to the power of 3 into x power is equals to 1 all over 2 raised to the power of 2. So we can rewrite this one as 2 raised to the power of 3x is equals to 2 raised to the power of minus 2. Remember, there's one of our law in indices that you can bring this one back to this form. Therefore, we have base equals base, equate powers. We have 3x equals minus 2. When you divide both sides by 3, you have your x equals to minus 2 over 3. Therefore, your log 0.25 to base 8 is equals to minus 2 over 3. That solves the whole problem. You understand? That solves the whole problem. So we also have some question like this format. You can be given something like this. Number 4, given that log 2 is equals to 0.3 whatever log 3 and log 7. Evaluate the following. You can see this kind of question in your exam, WAEC, JAMB, in your ND1, whatever level that you come across this kind of questions. You don't need to be scared. All you need to do is to break it down. Break it down so that you have 2, 3, or 7 in the factors of the number that appears in your question. Like A, this A, we have log 8. So what do you do? 8 can be 2 times 2 times 2, which is 8 now will be 2 times 2 times 2. Everything is to base 10. Log without any base is to base 10. It's assumed to be in base 10. You can do it like this and also condense it like log 2 raised to the power of 3. Log 2 raised to the power of 3. It will be log 3, 3 log 2. So what is log 2? You continue with your 3. Log 2 is 0.3010. So if you multiply it, whatever you have is your answer. We have 3 multiplied by this, which will give us something like this. We have 3 times 0, 0, 3 times 3, 1, 0, 9, 0. That gives you the answer. So let's take for number B, 5, log 5. Log 5. Okay, before I go to this next one, you can also see, multiplication changes to plus. So you can say log this from here, you can divide it like this, log 2 plus log 2 plus log 2, which will give you 0.3010 plus 0.3010 plus 0.3010. Your answer now will also come like this one. Your answer will be the same thing if you add them. So it's the same thing. So let's do log 5. This log 5, there is no factor of 5. Factor of 5 that you have 2, 3, or 7. It's a prime number. A prime number has to factor itself and 1. So what will you do? And we must make this question to contain 2, 3, or 7. So in this case, you go further to say log 10 over 2, because when you divide 10 divide by 2, you will have 5. You will have, so this will give us 5. This 10 log 10 over 2 is the same thing as this. So we can now write, remember, division changes to minus. You can write log 10 minus log 2. As I told you earlier, log without any base is assumed to be in base 10. To base 10. So log 10 to base 10 is 1. Minus log 2 will be 0.3010. So when you subtract it, you have 1 minus 0.3010. And you have 0.6990. That is your answer. That is your answer. So the last one, C, which is log 42. Log 42, we'll find the factors. Like we normally do, 42, what can go into 42? The factors, which is 2 here, we have 2, 1. What can go into 21? We have 3, 7, and 7 goes to 1. So log 42 equals 2 times 3 times 7. Can you see it? That is log 42. So we have this number already to be log 2 plus log 3 plus log 7. So you begin to substitute this value from what you are given. It's 0.3010 plus 0.4771 plus 0.8451 as given in the questions. So if you add all of them, you have 0.3010 plus 0.4771 plus 0.8451. And you have 1.623. 2 as your answer. So it's as simple as ABC. So that is that. If you have any question, put it in the comment section. There is nothing to be scared of. Also, I have another set of questions, which is still the same thing as logarithm. Like we wrote out the laws in logarithm in the previous video, you can apply them here. Like this number 5. Number 5. You have log this plus changes to multiplication and minus changes to division. You have log root 35 to base 10 plus log root 2 to base 10 minus log root 7 to base 10, which will give you log one of them, log 35 times, root 2 all over root 7, everything in bracket. So since all of them has square root, you can factorize it out as single to give you log 10 square root 35 times 2 over 7. 35 times 2 over 7, and that will give you 70. 70, which you have the square root of 70 over 7 to 10. So all you need to do is to divide it, and you have log root 10 to base 10, which can be written as 10 raised to the power of minus half to base 10. And you have log 10 10. Log 10 10 is 1. And then we'll have half as the answer. So let's do another one. Like number 6, please. We have log 350 minus log 7 plus log 2. All you need to do in this one is to bring plus, because this one has plus, even though it is not indicated. You bring plus to where there is plus and rearrange it. So let's rewrite it. Log 350 plus log 2 minus log 7. So like I said, plus change to multiplication, minus change to division. So you said log, take one of them, 350 multiplied by 2, this one, minus changes to division over 7. So you use your calculator to get it. Use your calculator to get it as 350 times 2. We have 700 over 7. And therefore, 700 divided by 7 is log 100. to base 10. As I told you earlier, any log without any base is assumed to be log 10. And so this can be written, you can solve it in index form, or you can go straight and say 10 raised to the power of 2, which is 100 to base 10, which will give you 2 come back log 10 to base 10. And log of the same base is what? 1. So your final answer is 2. That's your answer. It's 2. That's your answer. It's very simple. Even the remaining number 7 and number 8. If you want to solve it, let's solve one. I will leave the other one for you to solve. Number 7. We have log 3 over 5 all to base 5 plus 3 log 15 to base 2 all to base 5 minus log 81 over 8 all to base 5. So you bring this one in the middle number to the top to make it the power. But you can write it as plus changes to multiplication, division, minus changes to division. And will give us log base 5 and 3 to 5. Still keep this log 15 over 2, everything raised to the power of 3, minus log 81 over 8, everything in base 5. So in this one, we apply our laws of logarithm. Take 1, 3 over 5, multiply by 15 over 2, everything raised to the power of 3, divide by 81 over 8. This is how you write it. And so you can further break it down. This to be 3 log 3 over 5 multiplied by 15 over 2 times 15 over 2 times 15 over 2 all over 81 over 8. Everything in brackets. So you multiply the numerator and multiply this. What will you get? 15 raised to the power of 3. That is 15 times 3 times 15 into 3 places times 3 will give you log into 15 times 15 times 15 times 3 will give you 10, 125 over 2 times 2 times 2, 8. 8 times 5, we have 40. All over 81 over 8. Big brackets. Don't be confused. Still the same thing. So we change this one to division. Over 40 divide by 81 over 8. Do you understand? Because of this long division, you maintain it. But we will not go back to where we came from. We are solving what is inside bracket as normal fraction. So we have log 5. This one changes to multiplication in your fraction calculation times 8 goes up 81 comes down. So if you multiply that, what will you get? 10125 multiplied by 8. You have your 81. You have 81. Let's log 81,000 over 4 multiplied by 81. 4 multiplied by 81. 40, not 4. 40 multiplied by 81. You have 3,240 to base 5. And so when you divide 81,000 divide by 3240 will give you 25 to base 5. So automatically, you can raise this 5 raised to the power of 2 will give you 25. And you have your 5 raised to the power of 2 to base 5, which we apply our laws of indices. This one come back. Laws of logarithm, log of the same base, which is 1. And everything 2 multiplied by 1 is 2. It's long, but it's simple. It's just normal mathematics simplification. So if you come across this kind of question, don't hesitate to apply your normal knowledge. Don't look at it that it's too complex, simple. Just take it step by step and you arrive at the answer. Thank you and see you in the next video.